Good afternoon, everybody. The topic of my lecture is friction, its concept, types, and applications. First, we come to know about what is friction. Friction is a force between two surfaces that are sliding or trying to slide across one another. For example, when you try to push a toy car along the floor, that is, if we want to slide one surface over the surface of another, over the another surface, then there is some force that is called force of friction. Friction always works in the direction opposite from the direction of motion or the direction in which the object is moving, that is, it is always an opposing force. So it always slow down a moving object because it is in opposite direction. We can see here that if a person is moving in the forward direction, then force of friction is always in the backward direction, that is in the direction opposite to the motion of the person. Next, some concepts about friction. The amount of friction, it depends upon material. So the two surfaces which are made up of some material, so amount of friction depends upon the material. The rougher the surface, the more friction is produced. So the friction depends upon material. If friction is more, then the surface is rough, and vice versa. For example, you would have to push a book harder to get it moving on a carpet than you would on a wooden floor, because with the carpet it has more rough surface, so more friction as compared to wooden floor. This is because there is more friction between the carpet and the book than there is between wood and the book. So now the concept almost clear to everybody, I think. Friction also produces heat. For example, if we rub our hands together quickly, they get warmer. This is because of friction. Our energy converted to frictional energy, that is heat energy, sorry. So if we do the movement of our hands, then with this the work convert into heat energy due to friction only. Useful friction and reducing friction. Friction can be a useful force because it prevents our shoes slipping on the pavement when we walk and stops car tires guiding on the road. So friction is very useful force. It helps in many things, like if we want to walk on a road, then we can only walk with the help of friction. And another example also, like if we want to stop the car, so this is again the example of friction. Next example of the friction is ice causes very little friction, you know very well, which is why it is easy to slip over an icy day. But this is a good thing for ice skating and sledding. But if we want to move on the ice, then it is very difficult to move, because on the icy road there is very less friction, and if we want to move, then we require more friction as compared to this thing. Next example is, sometimes we want to reduce friction. For example, moving parts inside the car engine, they are lubricated with oil to reduce friction between them. So we lubricate the different parts of the car or the engine with the oil. The oil holds the surface apart and can flow between them, so there is less friction between the two surfaces because of oil. So reduced friction means there is less wear on the metal and less heat is produced. If the heat is if the heat produces less, then there is less friction between the two surfaces. So now we define completely the frictional force. When an object is in contact with a surface, there is a force acting on that object. The component of this force that is parallel to the surface is called frictional force. This is very important definition, that when two surfaces must be in contact with each other, touching each other, so there is some force which is acting on the surface which is parallel to the surface, and that force is called frictional force. This resistive force, resistive word here used because it is always in the opposite direction to the motion. If the body is going in the forward direction, then force of friction is always in the opposite direction. So this is resistive force. So this resistive force is exerted on a moving object due to viscosity or other type of frictional property of the medium, like in air or the surface in which object is moving. So frictional force also depends upon material, also depends upon medium in which the body is moving. So we can easily see how frictional force are taking place. When we are taking two surface, they are not plane, not smooth much. So the rougher surface, they get microscopic contact points. Because of that, we are getting frictional force. It is always opposite to the direction of the motion, or it is always opposite to the movement of the particle. Now some simple definition of the force of friction. It is always exerted by a surface to resist the motion of an object. And second point is, it is always parallel to the surface and it acts in the opposite direction of the object attempted motion. And finally it is denoted by F, small f means force of friction. Here in the picture we can easily see this thing. This is free body diagram. I will explain later, but we can I can somehow explain this thing. If this body has a mass m, so its weight is always acting downward, and the normal reaction exerted on this body by the earth is in upward direction. This is called normal force. Fn is called normal force. This is force acting on the mass of the body, that is weight. So if the particle is moving, if the body is moving in the right direction, so force of friction is always in the opposite direction and equivalent to this force. Next we come to the point that whether friction is good or bad. Sometimes friction is a problem, but sometimes friction is necessary. You already know all these things, but to cover all the things, so the friction is a problem where a sky puts wax on the skies to reduce friction between the skies and the snow. Like we already talked about this thing, on the icy surface there is less friction. So if we want to move on the icy surface, then we have to reduce the friction because of wax or sand, etc. And this is the biological application of the friction, that is synovial fluid helps to reduce friction between the moving bones in the joint of the human body. But sometimes friction is necessary, like a car that is starting to move require friction. If there is no friction, then we cannot start a car. And a person walking or running depends upon friction. So friction is good as well as bad depending upon situation. Friction is a force acting over the area of contact between two surfaces. If the two surfaces have more contacted area, then friction will be more. If the two surfaces have very less contact, then friction will be less. And it is always in the direction opposite to that of motion. There are two types of friction mainly, static friction and kinetic friction. Kinetic friction is also called dynamic friction. So the important point here is that friction is of main two types, static and kinetic, or it may be called dynamic friction. Now we come to the first friction type, that is static friction. So when the two surfaces are not sliding across one another, the friction is called static friction. That is, if the two surfaces they are rest with each other, then the friction is called static friction. It is also resistive force. You know, friction is always a resistive force because it acts in the opposite direction to the motion. So the resistive force exerted on the body up to the time just before the body start moving. So if your body start moving, then kinetic friction comes into play. But before that, before the body start moving, the resistive force which comes into play, it is called static friction of force. So we can see here three diagrams, A, B and C. So if we want to push a body, then we apply some force F and there is no movement on this body. So there is some static force, static friction acting here opposite to this motion. We want to move in this direction, but static friction is in opposite direction to the motion. So in the diagram B, next if we increase the force as compared to A, then this static friction is also increases, and at the moment final moment occurs when this force is maximum, this static friction is maximum. After that body just begins to move. So all these are examples of, first two are example of static friction, and this is the limiting friction. After that body starts moving. So we explain a little static friction. A force exerted on the stationary object by a surface that prevents the object from starting to move. So it prevents the object that it should not move. So here the force of friction which is acting, that is called static friction. It is denoted by Fs. So the object remains at rest because the static friction is equal to the applied force which is in opposite direction but with same magnitude. So the applied force and static friction, they have same value, same magnitude, but their direction is opposite. So the object remains at rest, but the moment occurs when this static friction becomes maximum. Fs maximum means the static friction becomes maximum. After that body starts to move. So for the object to move, the applied force which we apply, it must overcome the maximum amount of static friction, that is Fs maximum. This is also called limiting force of friction, that is this is maximum friction. Next we come to the dynamic or kinetic friction. So if if we apply a force on a body that is greater than this force, then body starts moving. So when the body starts moving, then the force of friction decreases. Then force of friction decreases because limiting friction is the maximum friction. After that, force of friction decreases, but the applied force increases. So the kinetic friction, it is the force exerted on a moving object by a surface. It is denoted by Fk. It acts in the opposite direction of the motion. Friction is always in the opposite direction. If the applied force is equal in magnitude to the force of friction, the object will move with a constant velocity. But if the applied force increases, then the object will accelerate. This is clearly the example of a car. If we ride a car or bike, if the applied force is same as the force of friction, then the object move with same velocity. But if the applied force increases, then the object will accelerate, or if the applied force decreases, then the object will de-accelerate. Now we come to next point, that is types of kinetic friction. Kinetic or dynamic friction we can divide into three parts. First one is sliding friction. Second part of kinetic friction is rolling friction. And third part is fluid friction or air resistance. So the first part is sliding friction. It comes into play when an object is scraping or sliding across a surface. If the one object is sliding over the another surface, then this friction is called sliding friction. Second friction is rolling friction. That is, if an object rolls across a surface, like if we roll a car or bike on the road, so this is called rolling friction. And third one is fluid friction or air resistance. It comes into play when an object travels through water or air and experience a drag. So when a body is in water, is on or is in air or in any medium, so there is some friction, that is called fluid friction. In fluid, two things are included, liquid as well as gases. So liquid means water and gases means air. But in space there is no resistance, there is no friction in space, because there is no medium in space. But water, there is medium water, and in air there is also medium, because air is made up of gases. So this friction is called fluid friction or air resistance. If it is in water, then fluid. If it is in air, then we can also say fluid or air resistance. Next we come to the point of coefficient of friction. This is very important point. So it is the ratio of force of friction to the normal force. We know if weight of the body acting downward and normal force is in upward direction. So from this we can define this coefficient of friction. Symbol for the coefficient of friction is mu. This is Greek letter mu. It is defined as force of friction to the normal friction, F upon Fn. This is mu. We can easily see, since force unit is Newton, here this is also force, its unit is also Newton. So Newton by Newton means no unit. So mu, coefficient of friction, has no unit or the direction, since it is a ratio of two forces. This force is frictional force and this force is normal force. And last point is coefficient of friction. It depends only on the type of material and can only be determined experimentally. For almost all the situations, the force required to start an object moving is greater than the force required to keep it moving at a constant velocity. That is, if we want to start a body, then force of friction obviously at that point is more, but when it starts moving, so the force of friction is less as compared to maximum friction. So this is limiting friction, this is kinetic friction. So when the body starts moving, then kinetic friction value is less as compared to limiting friction. This is very important point. I will explain pictorially also this point. That is maximum, this friction value is maximum. After that, when body starts moving, then its friction decreases. That friction is called kinetic friction. There are two type of friction. We know static friction and kinetic friction. So corresponding to these two types, we have two coefficients. First one is called coefficient of static friction, mu s, and second one is coefficient of kinetic friction, mu k. So there are two coefficients depending upon friction, type of friction, whether it is static friction or the kinetic friction. If the friction is static, then corresponding to that coefficient is called coefficient of static friction, denoted by mu s. And according to kinetic friction, if the body is moving, then the coefficient is called coefficient of kinetic friction. It is denoted by mu k. Next we define the coefficient of friction, static friction, sorry. So static friction comes into play when the body is not moving, it is at rest. So the force of the static friction keeps a stationary object at rest. So it is, this body is at rest, but if we apply a force in this direction, then friction is in opposite direction, in this direction. So here the direction is opposite as compared to applied force. This F is applied force, this Fs is static friction, this Fn is normal force which the earth is acting on the body. So we know static friction is equal to normal force into mu s, where mu s is the coefficient of static friction. On the similar lines, we can define kinetic friction. So if the body is moving in this direction, the force of friction is in opposite direction. So if the body is moving, then this is kinetic motion. So here the friction comes into play is kinetic friction. So if the force is in this direction, then force of friction is in opposite direction, Fk. Normal force is always perpendicular to the direction in which the body is moving. So once the force of static friction is overcome, the force of kinetic friction is what slows down a moving object. So Fk is equal to Fs into mu k, where mu k is the coefficient of kinetic friction. Static, here we completely define static friction as well as kinetic friction. Static friction opposes the impending relative motion between the two objects. That is, it resists the motion of two bodies. If the two bodies are not moving, that is resisting with each other, then the static friction comes into play. And second type is kinetic friction. It opposes the relative sliding motions that is happening. It is a resistive force exerted on the object during its movement. Normally it is much smaller than the static friction. I already told you this thing, that the kinetic friction is less than static friction. Because the body starts moving, so friction will become less. This is mathematical definition of Fk. Kinetic friction is equal to mu k into Fn. Mu k is coefficient of kinetic friction. Fn is normal force. Fk is kinetic friction. Fk is kinetic friction, and mu k is always lying between 0 and 1. We already know that mu is simply ratio of two forces, this and this, so it has no units. Its value is lying between 0 and 1. This is called coefficient of kinetic friction. And what is the direction of frictional forces? It is always opposite to the motion of the body. Next we come to the point why frictional force is there or kinetic friction is there. Kinetic friction can be modeled as the interaction between the identical teeth. We can see here the two surface. Here we take the example of book and surface, wooden surface or the carpet, etc. So these two surfaces are rough surface, not the smooth. If these two surfaces are smooth, then there is no friction, but if these two surfaces are rough, then there is more friction. So this contact of the book becomes with the contact of the wood. So the kinetic friction that can be modeled as the interaction between the identical teeth. The frictional force is spread out over the entire contact surface, and the displacement of the point of the application of the frictional force, it is not calculable. Therefore the work done by the frictional force is not calculable. Next, friction, some concept about friction. Value of the friction that can be calculated with the coefficient of friction mu. It depends upon material and surface as well as the medium. So F is equal to mu into Fn, where Fn is the normal force. So two coefficient we define for the static friction as well as kinetic friction. This is static friction, this is kinetic friction, is equal to mu into n, where n is normal force. We can denote also with Fn or n. Now we come to the important point which I already told you. If we increase the applied force on a body, then frictional force also increases up to this point, and this friction is called static friction. Up to this point, this friction is called static friction, and this is the point where the applied force is more as compared to this, but the frictional force is maximum, and this is called limiting friction. Here this friction, this value, total this value is called limiting friction, that is maximum friction. Then after that, if we increase the applied force, here if we increase the applied force, then frictional value decreases. Here we can easily see that force of friction decreases from this point to this point. So here the body starts moving, so the kinetic friction comes into play, but up to this point the static friction. Here at the maximum, where the frictional force is maximum, this is called limiting friction, and after that body starts moving, then this is called kinetic or dynamic friction. At some point the pulling force will be great enough so that the frictional force cannot prevent movement. Coefficient of static friction, you already know, mu s is equal to F maximum, maximum value of the force, divided by normal value of the force, that is normal force. So mu s is coefficient of static friction, F normal is normal force, F maximum is maximum value of static friction. So the coefficient of friction is a dimensionless number because it is the ratio of two numbers. It is unaffected by the mass of the object or the contact area. The greater the magnitude of the mu s, that is static friction coefficient, the greater the force necessary to move the object. So we require more force if the value of mu s is more. Next is dynamic friction. If the block starts moving, then there is frictional force that resists motion. It always resists motion. So these three are example of dynamic friction.